Very warm good morning to you all children. Hope after Onam holidays and all you have enjoyed Onam and now we are back to our classes. Before Onam holidays we were discussing about LCM and HCF. HCF was highest common factor and LCM was lowest common multiple, isn't it? So I have told you that HCF, whenever the word problem comes for HCF, they will not ask you to find HCF, they will be giving maximum, highest, biggest and all. For LCM, they will be giving lowest, smallest, all those words you have to look for, isn't it? Now, I told you there is, even if it is smallest or greatest, there is something you have to look beyond that, and those are the problems I have brought you here today. Okay, see here, determine the smallest three-digit number which is exactly divisible by 6, 8 and 12. Okay, the word is smallest. So when it comes smallest, you will immediately say, madam, it is LCM. Okay, smallest means LCM. But the word here you have to look is not for smallest, you have to look for the word divisible, children. You have to look for the word divisible. Why? Because any number, now if you have to find the factors of 6, if it is HCF, highest common factor it is, then factor is always smaller than the number, smaller or equal to the number given. That is, the number will be less than 6, less than 8, less than 12 or equal to this. So equal to 6 maximum it can come. But if it is less than the number, then is it divisible? Can you divide that number completely? Can you divide the number completely? No, it is not possible. So, whenever the word comes divisible, irrespective of whether it is smallest, greatest, biggest or anything, you have always to find the LCM. Okay, so the word you are looking for is divisible. If anywhere the word comes divisible in this word problem, then you have to understand that divisible means you have to find the LCM. Okay, when it is a multiple only, then you can divide it. Okay, factors cannot be divided by the number. For example, 2 is a factor of 4, but then you cannot divide 2 by 4 completely. You will get a fraction. Understood? You are going to get a fraction. You cannot completely divide this. Clear? Likewise, 3 is a factor of 12, but 3 cannot be divided by 12. Understood? So we have to find a 3-digit number which is exactly divisible by 6, 8 and 12. Now let us start. So you have understood now that we have to do the LCM. So we'll start with 6, 8 and 12. Now we have to find a number that goes in all the three. That is 6, 8 and 12. We can divide it using which number? Look at the last digit in the units place. It is 6, 8 and 2. Looking at the digits in the units place, we know that we can divide it by 2. Divisibility we have already learned. All the three numbers we can divide it by 2. 3 2s are 6, 4 2s are 8, 6 2s are 12. 3, 4 and 6. Now is there any number with which all the three can be divided? With 2? No, 3 cannot be divided. So what we understand is the divisibility, the factors finish here. That is, highest common factor is going to be 2. Highest common factor is going to be 2. But we are not going for HCF, we are going for LCM. So again we divide it by 2. We cannot divide 3, so we write it as it is. Then we write 2 2s are 4, 3 2s are 6. Again we divide it by, either you can divide it by 3 or you can divide by 2. Okay, here I will divide it by 3. So I get 1 3s are 3. 2 I cannot divide, I will leave it as it is. You should remember children, only when we go for finding the LCM, we should be dividing it this way. For HCF, when we are finding all the three numbers, how many numbers are given? All the numbers should be divisible. We cannot just pull it and bring it down for HCF. Only for LCM we'll do that till we get 1 1 1. Now what do we get? LCM is equal to 2 into 2 into 3 into 2. So what is the answer? That is 24. LCM is equal to 24. When you get LCM is equal to 24, this is only 2 digit. isn't it? Now we are asked to find the 3-digit number. We are asked to find the 3-digit number. Now how are we going to find the 3-digit number? Multiples of 24. You have to see the multiples of 24. 24 ones are 24. 24 twos are 48. Now we know that 24 into 4. 4 into 2 is 8. 5 into 2. Let us just count and see. 24 into 4. That is 4 4s are 16. Carry over 1. 4 2s are 8 plus 1. 96. And then I take 24 into 5. Then I get 5 4s are 20. Carry over 2. 5 2s are 10 plus 2. 12. I get the answer 120. Therefore, smallest 3-digit number exactly divisible by 6, 8 and 12 is 120. Got it? So the smallest 3-digit number that is exactly divisible by 6, 12, 8 and 12 is 120. Now how did we do this? We'll recollect once more. We are going for divisible numbers. So whenever there is divisibility or divisible, we have to go for the LCM. When we go for the LCM, then we got LCM as 24. Now 24 is not enough. We need the smallest 3-digit number. 24 has got only 2 digits. So we are going to find the multiples of 24. Okay, LCM is about multiples. So we have to find the multiples of 24. 24 into 1 is 24. 24 into 2 is 48. 24 into 3 is, so what you do is, you multiply 2. That is 24 is there. 24 into this 2 when you multiply. 2 into 1 is 2. 2 into 2 is 4. 2 into 3 is 6. 2 into 4 is 8. 2 into 5 is 10. 2 into 5 is 10. So it is going 1 digit extra. Isn't it? Otherwise, wherever you take 2 ones are 2, 2 twos are 4, 2 threes are 6, 2 fours are 8, all are in 1 digit. When it comes to 5, 2 fives are 10. Understood? So it has to be 5 or the just before number 4. That is why I have multiplied by 4 unseen and I have multiplied by 5 also unseen, and then I got that multiplication by 5 gives me the first 3-digit number. Therefore, 120 is the smallest 3-digit number divisible by 6, 8 and 12. Now, determine the greatest 3-digit number exactly divisible by 8, 10 and 12. Now you have to see greatest. Divisible is given. So what are we to find? We have to find the LCM of 8, 10 and 12. So let us start finding the LCM of 8, 10 and 12. So as I take 4 2s are 8, 5 2s are 10, 6 2s are 12. Again I cannot divide it so completely. So HCF is over. HCF will be 2. Now we are moving to find the LCM. 2 2s are 4, 5, 3 2s are 6. Then I have to divide by 2, 1, 5, 3. I have to divide by 5. I'll get 1, 1, 3. And then I have to divide by 3. I'll be getting 1, 1, 1. So LCM of 8, 10, 12 is equal to 2 into 2 into 2 into 5 into 3. That is 2 into 2 is 4 into 2 into 5 is 10 into 3. 4 3s are 12. 12 into 10 is 120. So we get the LCM as 120. So children, once we get the LCM as 120, is it enough? Yes, they have asked about 3 digits, so we got the 3-digit number. But is it the greatest? Is it the greatest 3-digit number? No, it is not the greatest 3-digit number. We know the greatest 3-digit number is 999. Isn't it? So now we have to find out that which will be the greatest three-digit number that we can take to finish this. How are we going to do it? Yes, you have to find the multiples of 120. 120 into 10, if you think, it becomes 1200, isn't it? 120 into 10 is what? You have to just add 10, 1200. So it becomes 4-digit number. We don't need 4-digit number, we need only 3-digit number. Now we'll try with 120 into 9. Then what you get? 9 to 0 is 0. 9 2s are 18, carry over 1. 9 1s are 9 plus 1, 10. 1018. Oh, that is also 4-digit number. So now we'll try with 8. 120 into 8. 8 zeros are 0. 8 2s are 16. Carry over 1. 8 1s are 8. 8 plus 1, 9. 960. Okay, 960. This, after that, next when you multiply by 9, you are getting 4-digit number. This is a 4-digit number. So which is the greatest 3-digit number you are getting? It is 960. It is 960, children. So what we do is, so that is the greatest 3-digit number. Okay, so we can write here, therefore, the greatest 3-digit number divisible by 8, 10, 12 is 960. Got it? Now, find the least number which when divided by leave the remainder 5 in each case. That is, we have to divide a number by 6, 15 and 18. So the word here it is divided. So what are we supposed to find? Factor or multiple? We have to find the multiple. We have to find the LCM. So what we do first is we are doing 6, 15, 18. First we'll find the LCM. 3 will go in all the 3. 2 3s are 6, 5 3s are 15, 6 3s are 18. Then we'll divide by 2. Our HCF is over. There is no common factor here. So we have 1 2s are 2, 5 and then 3 2s are 6. Again when we divide with 5 we get 1, 1, 3 and again with 3 we divide we get 1, 1, 1. So LCM of, why I am doing fast is by now you have understood how to do the LCM. You can do it on your own. I am just showing you how to complete it. So LCM is equal to 3 into 2 into 5 into 3. What is the answer? 3 into 3 is 9. 9 into 10. You should always find out easy way for calculating. So 9 into 10 is 90. So you're getting the LCM as 90. Now what is the question? Is the question over? Find the least number. Least number means it is the LCM only. So the least number is 90. We have got the answer. But that is not enough. Find the least number which when divided by any of these numbers 6, 15 and 18 should leave remainder 5 in each case. Now we know that if it is the LCM, then 90 divided by... So children, we got the least number as 90, but when you divide, that is what I was saying, when you divide these numbers, so 90 when I divide by 6, or I divide by 15, or I divide by 18, 6 when I divide 1 6 are 6, then 3 remainder 30, 5 6 are 30. So 15 times remainder is 0. Now the question is, you have to leave remainder 5 in each case. You have to leave remainder 5 in each case. Now how are we going to leave this remainder 5 in each case? That is, here instead of 0 you should have 5 as the remainder. Now if it has to come as 5 as the remainder, then here it should be 5. That is 90 plus 5. When you take 95 and you divide by 6, then you will get 35. 5 6 are 30 and you get the remainder as 5. So in each case, if remainder has to come as 5, in each case when you know that the 90 is the least common multiple, then 90 when you divide by 6 or 15 or 18, you are going to get the remainder as 0. But if you have to make the remainder 5, then you have to add 90 plus 5. Okay. So least number, so our answer will be least number that leaves remainder 5 when divided by 6, 15 and 18 is 90 plus 5, that is equal to 95. That is whatever is given as remainder, you are going to add that to this number. Okay. Now same way children, sometimes question may come that the remainder is 6, 15 and 18 and it leaves remainder 2, 3 and 5 respective to 6, 15 and 18. Find the numbers. Okay. So we get the LCM as 90. Then for 6 they have given as 2 remainder. So for 6 it will be number will be 92. For 15 the number will be 90 plus 3, that is 93, and for 18 the number will be 90 plus 5, that is 95. Okay, such questions come for competitive examinations. Now you understand only this. When there is smallest number that is left, then you have to do it this way. Is it clear? Yes. So what we have done is we have found the LCM, but LCM was not enough. That number when divided by these three numbers, they should leave the remainder 5. So when the remainder is 5, we add that number, the remainder, to the least common multiple. Okay. Now find the smallest 4-digit number which is divisible by 18, 12 and 32. Smallest 4-digit number. Divisible. Again we have to find the LCM. You have to find the LCM of 18, 24 and 32. Now once you find the LCM, you have to find the 4-digit number. This I am giving you, this question I am giving you as homework. Okay. In the next class I will be asking you the answer for this. So you'll do it on your own. You have to find the LCM of these. And then once you find the LCM, you have to find the 4-digit number, smallest 4-digit number. So the same way you can continue and you can find it out. Now the factor tree. How to make a factor tree is the question. Write the prime factorizations of 16, 28 and 38. So first I take 16. How to write the prime factors? That's the question. If I take 16 children, I can write it as factors. You know how to write. 2 is a factor. 2 and I've told you how to write it. First you write 1, then you write 16, then you write 2, then you write 8, then 3 will not go. 4 4s are 16, so you write only 4. Now, if you are asked to find the factor tree of 16, how will you write? 2 into 8. First one will write 1 into 16. Okay, so how we are going to do this factor tree?